Hello, in this video we're going to do our first JASP demo for multiple regression. So for this one, we've got the multiple regression question: how do credit hours, work hours, and age influence how much someone works out? So this is important to note. Even though it says influence, all right, it means predict. So if you see influence, think predict, and then when you actually write up the hypothesis, do not leave in influence. Change it to prediction. So if you see influence, think prediction, and then write in your hypothesis prediction, right? So there's my little tip for the quiz or for even your own assignments, right? So big thing for multiple regression or even linear regression, your hypotheses need to be in terms of prediction. Even if the original research question says influence, you want to put it in terms of prediction. So in this case, our null is that there is no significant prediction. So remember, null is always that there's nothing happening, right? So there's no significant prediction of time spent exercising. So that time spent exercising, that's our dependent variable. That's our response variable. That's the thing we're trying to measure by credit hours, work hours, and age. Now, those are going to be our independent variables. Those are our predictor variables. So other important thing, all of these are numeric. So time spent exercising, right? That's numeric. How many hours do they spend exercising? Credit hours. How many credit hours does someone take? That's numeric. Work hours. How many hours do they work? And age. Those are all numeric variables, which is why we can do the multiple regression. Then the alternative is that there is a significant prediction. So null is that there's no significant prediction. Alternative is that there is a significant prediction. Now let's go ahead and do this in JASP. So first of all, this is the Math 113 data. This is legit data. I think I talked about this last week, just that this is real data. I teach a community college class, Statistics 1, and so this is data, anonymized, obviously, so that way you could never tell which students are which, but this is real data. This is not fake data. So remember, once again, we're doing a multiple regression. So we're going to come up to, double check. So the very first thing you need to do is double check, make sure all your variables in the correct format. So first of all, exercise, right, is listed as a scale variable, which it needs to be because all of your variables have to be scale in order to do that multiple regression. You can also see that it's a numeric variable, right? We've got a wide range of numbers here. We then have credit hours, also listed as a scale, because remember scale, if you want to make a little cheat sheet, scale is equal to numeric. So if you've got numeric variables, they need to be listed as scale. We then have work hours, also scale, and you can see they are numeric. And then we've got age. Age is also a numeric variable, and it's listed, or scale / numeric, and it is listed, you can tell, right? It is numeric. So we are good to go there. So next, we are going to come up to that regression. And if we were doing a correlation, that's where we would go. If we were doing a linear regression, this is where we would go. But, because remember how I said linear regression and multiple regression are extremely similar. The only difference is extra predictor variables, right? Extra independent variables. So we're going to go ahead and do the linear regression. We're just going to have, instead of just one covariate, we're going to have more than one covariate. That's what makes it the multiple regression. So in this case, our dependent variable, remember that's that response variable, and that was exercise, because we want to see if our predictor variables, right, or if our predictor variables can then predict how much someone exercises. Then for our covariates, we're going to add in credit hours, work hours, and age. So you can see JASP is going to automatically just start tabulating for us, but we also need to open up statistics and we need the Durbin-Watson value. So we need that, and otherwise we are good to go. You do not need anything else. In looking through here, we've got some important different variables. The main one, so if you're interested, you're like, okay, this is great, but what's the actual, what p-value are we looking at to determine if this is significant or not, right? Because there's a bunch of p-values here. What we're looking at is this p-value in the ANOVA model. And I know you might be like, wait, ANOVA? I thought we were doing a multiple regression. Yes, we are, but the multiple regression is based off of an ANOVA model. So I'm not going to go into more detail because just trust me, it works. And it would that's kind of that deep dive into the weeds that most of you would probably prefer I didn't do. If any of you really want to know that relationship between regression and the ANOVA model, let me know. I'm happy to go into more detail, but for this class, we're not going to dive into the weeds. Just trust me, it's the p-value for the ANOVA model is the overall p-value that you're interested in. And so what this p-value means, so think about it, right? Is this p less than or equal to 0.05? Yes, it absolutely is because it's very small. And so what that means is that our results are significant, right? So we're rejecting the null, our results are significant. In terms of degrees of freedom, we're going to use the 3 and the 27. So this is something for the regression. You need 2 degrees of freedom. It's going to be the 3 and the 27. So the regression and the residual. The 3 comes first, and then you have a comma and a 27. And then our F value, the 18.86, that is the other main value that we need from this test. And so you can kind of see this over here. So what do the initial results mean? The p-value is significant, so results indicate there is a significant prediction of exercise by credit hours, work hours, and age. The null hypothesis is rejected, and this is all important information you would want to include. Then in terms of the correct write-up, you can see we've got our F, then our degrees of freedom, that 327, then we've got our 18.86, that's our F value, and then we've got our p-value. Also note, and this is important, that F value and that P value, or F value, that F, the literal letter F and the letter P are italicized, and that's per APA. So make sure to italicize the F and the P. So that's what our initial results are, but there's so much more. So one of those is the Durbin-Watson value. And so Durbin-Watson checks for correlations between residuals, that's the difference between observed and expected outcomes, which can invalidate the regression test. So the Durbin-Watson value should be above 1 and below 3. So for that Durbin-Watson, because remember we checked the box right there for Durbin-Watson. And so you can see, here's that Durbin-Watson information. And what we're specifically looking at is for the H1, and the statistic, and that's that 1.562. We want that Durbin-Watson value to be between 1 and 3, so we are good to go. So this is a good value for Durbin-Watson, so green light, excellent. Now, even if this value was below 1 or above 3, you would continue to write up the results. You would just indicate in your written results that that Durbin-Watson value did not fall within the parameters that it should, and that could potentially invalidate your results. So you would still write up all of your results. You would just indicate that this Durbin-Watson value really throws things off. So really important, don't get to this point, say, oh, Durbin-Watson's bad, I'm just quitting. You still have to write up the results, whether it's for an assignment or for the quiz. Just keep running with it. Just acknowledge that that's not a good value. Now, granted, in this case, it is a good value. So this 1.562 is above 1 and below 3. So yay, green light. Keep moving. The other value that we want to look at in this model summary exercise is the adjusted R-squared value for H1. So this is 0.641. Very important for a multiple regression, you're always looking at the adjusted R-squared value. For a linear regression, it would be R-squared, but as soon as you add in extra predictors, then you've got potential for error, and that's why you have to use the adjusted R-squared. So multiple regression is adjusted R-squared. In this case, it's a 0.641, which this ends up being a percentage, so you multiply that by 100 to get 64.1%. And what that means is that this model can account for 64.1% of the variance in how much someone exercises. And so for that one, the adjusted R-squared lets us know how much variation in the outcome variable, the dependent variable, that's exercise, is explained by the independent predictor variables. So in this case, right, it's 0.641, and then I've got the table right here, and you can see the 0.641 lands in the good section. So a good amount, 64.1% of the variance in hours exercised per week, is explained by credit hours, work hours, and age. So that means that more than 50%, right? So, right, we're actually hedging into, well, we got into almost 2/3 of the variance in hours exercised can just be explained by how many credit hours someone takes, how many hours they work, and their age. So that's what that means. And that good amount comes from the strength of fit. So if if it was fair or poor, you would just substitute out good for poor or fair. But this is exactly how you would write that out. For APA, you would also include it here. So you would have, remember, this was our initial results right there. And then you would put in that the adjusted R squared, italicized, is equal to 0.641. And so then you would put a period, and then you would normally put this sentence. And don't worry, we're going to write this. We're going to show how to correctly write it up and all of that information. So after this, what is next? Let's see, we covered that. Oh, so how do we determine the multiple regression formula? So this is important just to help you understand how much, right, each of these, so credit hours, work hours, age, how did they actually impact the overall model, right? Because we know 64% approximately, right, of the variance can be explained by those, but let's look at a little bit more of how exactly do those variables play into that overall exercise. So where you're going to look at for this is the coefficients table. Specifically, you're looking at the intercept, which think about this as almost like a y equals mx plus b. That's your intercept. And then the credit hours, work hours, and age are going to be all of your other little covariates in there. Also, really quick, these p-values. The p-values let you know if these are significantly impacting the overall model. So we know the actual model is significant, but this, so credit hours is less than 0.001, work hours less than 0.001, and even age, it's 0.03, but that is less than or equal to 0.05. So in this case, all three of these predictor variables are significantly impacting the overall model. Now, if one of them was above 0.05, then that would mean they are not significantly impacting the model. And you could even suggest getting rid of a variable if it's not significantly impacting the model. Now, sometimes if you do that, your adjusted R squared goes down. So it's kind of a fun back and forth, because you want a high adjusted R squared. You actually want a low number of predictor variables, but you really do want them to be significant. So, sorry, just something to think about. I told you I love and I get excited about multiple regression. I think it's so much fun. So back here, let's go ahead and take a look. And so you've got, these are the variables that you need to write out. So you can see that intercept is your constant. That's that negative 0.488. Also this y hat is exercise. So ultimately this means exercise is equal to negative 4.88 plus 0.942 times the number of credit hours someone is taking plus 0.333 times the number of work hours someone works minus 0.408 times their age. So that minus and the age, right, it actually means, right, that there's a negative impact in terms of age. So this is a negative relationship in terms of the younger someone is, so the less the age, so if age goes down, exercise goes up. If age goes up, exercise goes down. And you can tell that by this negative in front. And you can also see this age has got a negative value here. That's how you know it's a negative relationship between age and exercise. Credit hours and work hours are both positive, so you know that they're positively related. So interestingly enough, the more credit hours someone takes, the more they exercise, and the more work hours someone works, the more they exercise. But age is flip-flopped, right? So the younger they are, the more they work out. The older they are, the less they work out. So obviously you can chew on that and think about those results, because remember, this is real legit data from my community college class. So what does this mean in terms of real world? Well, let's go ahead, because remember I said that's the number of credit hours, work hours, and age. So let's go ahead, where did those numbers come from? And take a look right up here. And so here we've got 13 credit hours. So this is just the very first person, right? They have 13 credit hours, 35 work hours, they're 22 years old, and they exercise 4 hours per week, right? So that's our actual real data. So if we come in here and plug this in, so remember this is the constant. So we take the 0.942 times 13, which is the number of credit hours, plus 0.333 times 35, which is the number of work hours, and minus it by 0.408 times 22, which is their age. And also note, you do not, so sorry, I should have, put a little asterisk by this. You are not going to be required to do any of this for any exam or assignment. I am purely doing this to help you understand what a residual is and the difference between observed and expected in terms of this modeling. And the reason for that is that I want you to feel educated and knowledgeable, but quite frequently when you are reading research articles, you are going to hear about residuals. You're going to hear about observed and expected. So I just want you to understand kind of mathematically where that's coming from. But this is not 100%. This is not required for the exam or for any quiz, not for the final exam, not for any assignment. So you never have to do this. This is purely me wanting you to feel, like you are getting the most out of this PhD program, right? This is all I'm doing. But so if you go ahead and you do the math for that, you would assume that this person should exercise on average 10.05 hours of expected exercise. So that's the expected is 10.05 hours. But up here we saw this person only worked out 4 hours per week, right? So that's like a 6-hour difference. The difference between the observed and the expected are called residuals. Now, this is one student. If you were doing this by hand, which unfortunately, because I have been around for a while, I have had to do this by hand. So before, we got to use JASP and all of these fun, amazing, SPSS and those programs, I have had to do this by hand. So I've had to figure out the residuals by hand. Not a lot of fun because you do this, you would find the residuals for every single person, add them together, toss them into a formula, and then that's what impacts that Durbin-Watson value. Because you remember I said the difference between observed and expected can invalidate. So if you have too much of a difference between the observed and the expected, it can invalidate the results. What else it can do is impact this adjusted R squared, because the adjusted R squared has to do with, right, those residuals. And the bigger the residual number is, so the bigger the difference between your observed and expected, the lower the adjusted R squared. Because basically, the bigger the difference between the observed and the expected, it means the less, good or less good. That's horrible grammar. See, I teach math, not grammar. The lower, right, the prediction power is, right? So there's not very good predictor if there's that huge difference between observed and expected. So if it's not really good at predicting, you're going to have a lower adjusted R squared. So that's where all of that, all of this fits into those areas. So once again, I promise you're never going to be required to do this. I just want to make sure you understand it, but you will never be tested on it. In terms of how do you interpret the rest of the table, so remember I had that talked about these and the significant level, and so how you could actually write it up is that when other predictor variables are held constant, there is a significant positive relationship between credit hours, work hours, and exercise. So remember I said credit hours and work hours, right? They're both positively related to exercise. There's a significant negative relationship between age and exercise, because remember there's that little negative sign, so that means there's a negative relationship. This indicates that the more credit hours someone takes, the more they exercise, the more hours someone works, the more they exercise, and the younger someone is, the more they exercise. So that's how you interpret that part of the table. And so then in terms of the write-up of results, so for your quiz 3, this is the type of thing that I'm looking for, and you really do need this information. So you absolutely, if you want full credit, you need the Durbin-Watson value. You need this full thing, you need this full regression equation. You need to say, that it is significant or non-significant. You need to say if the null hypothesis was rejected or not. So really mission critical. When you go to write up your results, you can literally use this as a template for your quiz, for your assignments. So when you start analyzing your own data, you can use this format right here as a template and just write up your results, plugging in what you get into this overall kind of generic write-up. Even though this isn't generic, but I hope you get what I mean. So for this case, a multiple regression was calculated to predict hours spent exercising per week based on credit hours, work hours, and age. Durbin-Watson value was normal, indicating a valid test. A significant regression equation was found, and the null hypothesis was rejected. Make sure you include all that. That's really important. Then you would put in, right, your information. Make sure you italicize F, P, and adjust it R². Then you would say a good amount, that 64.1% of the variability in hours spent exercising per week is explained by a person's credit hours, work hours, and age. Then you would include that the regression equation for predicting exercise is, and that information. And then you would include this last part, which is what we just covered in this slide right there. So that is everything that you need for, I know you're like, everything. You just spent like 21 minutes talking about that. Okay, well, this was one example, right? And I had to go through a lot of different, details here. So the next example will hopefully be much quicker, but I hope this helped, and I'll see you in the next video.